So it was really a kind of evolution, my research. So it does actually, it's quite a long story. I'm actually a microbiologist by trade. That's why I did my PhD in, and my first fellowship was at St Andrews University in Scotland. I was really in that university, I was studying life in volcanoes, and we're discovering how on earth these small organisms that lived in there managed to live in basically boiling sulfuric acid. We're particularly interested actually from the genetic code of these microorganisms. So they're too small for us to see. So they're not like fish or anything like that. They're like bacteria. They're single, very small animals that live in there. But they protect their genetic code, and we're trying to figure out how on earth they protected their genetic code in there. And that lab discovered a new family of proteins in these organisms. They're called archaea, which means ancient. But the really interesting thing is that we're actually related to these organisms. So about 2 billion years ago, we had the same past, and we've evolved from them to be what we are today. And so when we found this protein basically protected the genetic code from the damage. Now, damage to your genetic code is what drives aging. It's a single factor that drives aging and cancer and all these other diseases associated with aging. So that was really interesting to me was, well, where else in life would we find this protein? And when we did a search, we found it in the human genome. So we found the exactly same protein. Now, if nature doesn't change anything for 2 billion years, you know it's pretty important. And so we did a lot of work on that. We published in Nature describing this family in humans for the first time. And what's really important this family is that they're there to protect our genetic code from cancer. But when cancer comes, the cancer actually uses it against us. So it uses it to evolve, to become drug resistant. So you may know that people get chemo, more or less all of them become resistant to chemo. And this is driven by the genetic change, which is allowed by this protein. And so we've actually developed a drug against it. So this protein is all cancers, every cancer, whether it's prostate, breast, melanoma, they're all addicted to this protein. If they don't have this protein, they can't survive. So we've developed a drug against this protein, goes into patients hopefully about September this year, August, September this year, if the coronavirus allows us. And it's aimed to actually tackle all cancers. So it's designed to work more effectively than chemo, without the toxicity of chemo, and really be able to tackle all cancers.